Hi, welcome to episode 3. The subject of this episode is digital thread. I will discuss what digital thread is, how it is created, how it is maintained, and how it is used. Once again, welcome. If we look at a small subset of this model dealing with real-world products that is produced and perhaps in usage, we can see that there are many classes but even more relations. The good thing with the relations is that they are used to create a digital thread. By using these relations between different classes of product information, we can trace and understand the relation through the life cycle of the product, both going forward, but even more important, going backwards. If we look at an even more abstract view of this, we can see that we have requirements, requirement breakdowns, we have functional breakdowns, function traceability, we have systems, system breakdowns, and system relations to functions that they deliver or the functional requirements that they fulfill. We have spatial breakdowns and we have physical breakdowns. And we can assign relations between them, but also we can also assign requirements to all this. So we can see that this system delivers this functionality. This system is placed in this room and so on. We also deal with parts and assemblies, designed solutions for this different kind of abstract components that needs a real-world solution. And we support these relations, that this system consists of these parts. This part delivers this function and so on. We also use the definition of parts and products to build, to instantiate real-world products. Product that's in real world of 3 dimensions and time. These real-world products, they are in one place at any time. We deal with change requests, change ideas, change approvals. We can change the definition of something, we can change the real world product. In reality, we can deal with changes for all these objects. The same goes for documents. We can connect any set of information to all these objects. It could be 3D models, could be bitmaps, photos, documents, or anything. But good thing with all this relation that I talked about now is that you can use them to build a digital thread, going from the left to the right, going forward, from the right to the left, backwards. And that way we can build a lot of knowledge, or this structure contains a lot of knowledge. Knowledge in the digital thread. Let's say that the product is broken during usage. What is the reason? It is maintained according to its maintenance schedule? Question mark. The maintenance activities and the maintenance schedule, is that the problem there? Have they carried out all the maintenance activities? Was there a problem during production? Non-conformance record perhaps was assigned to the product instance? The design of the product, does it fulfill the stated requirements on the product? Was the current usage for the product instance covered by the stated requirement? Or was the product used for activities outside the comfort zone of the product? And so on. Long time ago, not so long time ago, all this had to be done by tracing information, using IDs between drawings, documents, specifications, handbooks, and so on, to understand and build knowledge about what was the reason. Today, all of this is available in seconds instead of months. But different participants in the product lifecycle can also use this for different things. A customer, he can use it to figure out if he's using the product inside the comfort zone of the product, or is he jeopardizing the warranty. The production engineer, perhaps he had no NCRs connected to a product, but they see using the digital thread that when a specific robot, a physical robot, was involved, they always have a problem. Perhaps that robot use too much torque for the assembling. The designers, they have a product that's used according to the manuals, but still they have a problem with some components, but they were not recognized in the FMECA. That's also a way to build knowledge. Next time they do FMECA, they can see that they have a potential problem if they do things like they did at this time. To systems engineers, perhaps when they think about how to realize subsystems, they can see that they have problems when they buy the subsystem from a specific supplier. These were just examples. Of course, there are many other ways to use this holistic data set. And since there are all these relations, there is a lot of knowledge to build from this. I try to explain how we build, how we maintain, and how we use the digital thread. Thank you.